Hi Year 9. So we are going to start today with a little bit of self-quizzing again, just like Tuesday. So if you get your self-quizzing booklet out and go to page 11. So on page 11 there are a bunch of questions that you have to answer. So the exact same process as I outlined on Tuesday. If you can't remember, if you go back and watch that video, then you will be reminded about that. Quick summary though, here's the question. This wee number tells you what section in the knowledge organizer sheet that you get the answer from. So the process is described up here, and if you use your knowledge organizer to answer for the first time, second time on page 12, you try and answer from memory, and then you get your knowledge organizer out and you correct your work again, and then spend a bit of time trying to learn what you got wrong, especially, and then you do that again. So that process should take about 20 minutes, and whenever you're doing your corrections, you are correcting it in a different colour. Okay, so do spend proper amount of time on that, because pretty shortly we're going to start mixing up all of these questions at the start of our lessons to keep on top of our information from the whole way throughout the year. Okay, so spend your time on that now. Okay, after you've done your self-quizzing, if you go to page 161 in your notes, we're going to work through the last little section in this space topic. Okay, so we're going to be talking about space distances a little bit today, and as I have said before, the distances that we are talking about here are so big that we can't really visualize them. At the end, well, I suppose just in the lesson, I'm going to link a couple more videos, a couple more YouTube videos to try and help you visualize the type of distances and the sizes that we're talking about, because it is really hard to wrap your head around it. Okay, so because the distances that we're talking about to do with space are so big, if we were to always be talking about them in meters or kilometers or anything like that, they would be like ridiculously high numbers. So there's a set of different units that are often used whenever we're talking about space. So the first one you've probably heard of, it's a light year. So a light year sounds like it's going to be a unit of time because of that word year, but it's actually a measure of distance. So make sure you're filling this in with me, please. And it is the distance that light travels in a year whenever light's in a vacuum. So the distance light travels in a year in a vacuum. Just to remind you, we talked about what a vacuum was whenever we were learning about infrared radiation. Do you remember? It's whenever there's no particles whatsoever. So space itself is a vacuum. So that massive distance that light travels in a year, that's called a light year. So that's a measure of distance, and it's used to record distances, I suppose, in space. So I'm not even going to try and read that number, but that's how many kilometers it is. The speed of light is, I always write it like that, 3 times 10 to the 8 meters per second. Now, you've maybe been learning about standard form and maths. If you have, you'll be able to change that, but that is, let me just check this. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 300 million meters per second, which means every single second light travels 300 million meters. Mental. Okay, so how long does it take for light to travel to the moon? Now, know the way we we skipped on to this topic for online learning because we thought it was a wee bit more suited to online learning than the other stuff that we're doing, which we're probably going to end up doing online anyway. One of the things that we haven't actually done yet then is how we would carry out this calculation. So I'm just going to take you through that. So how long does it take for light to travel to the moon? We've been given the distance, we have been given the speed, and we've been asked to find the time. So you will be learning this at some stage this year, and normally, as I say, normally by the time we get here you would have done this already. The equation that we use for calculating speed is speed equals distance divided by time. Now if I wanted to rearrange that and make time be the subject, I would multiply both sides by t and then divide by s, and I would get distance over speed. So this is the version of the equation that we are going to be using here to do this. Okay, so over here, start off, remember we were just doing our moments calculations? Similar layout, you start off by writing out the equation. Distance is this many kilometers, so 384,400 divided by the speed, which is 300,000 kilometers per second. So if I type that into my calculator, I get that, so 1.28. Now be careful with units, let's check them. If we have distance kilometers and we're dividing by kilometers per second, that means that's our unit in seconds, so that's our time in seconds there. Okay, so it takes 1.2, really that should be 1.3, like, shouldn't it? Change that please. Seconds for light reflected off the moon to reach us on Earth. Now we're going to fill in these other ones here. Okay, now I want to also talk about what these numbers actually mean. So how far away are space objects from Earth? So we just figured out there that the moon is 1.3 light seconds away from Earth. So that means that it takes 1.3 seconds for the light that's reflected off the moon to reach the Earth. So whenever we look at the moon, we're seeing it as it was 1.3 seconds ago. Now, that doesn't sound like much. However, whenever we look at some of these other ones, so if we look at the sun, it's 8 light minutes away. That means that it takes the light 8 minutes to reach the Earth from the sun. So I know you shouldn't look at the sun because you'll damage your eyes, but if you look at the sun, you're actually seeing how it was 8 minutes ago. Isn't that crazy? Now, even more than that, so the Voyager, it's a space probe that was sent out many years ago, and it has reached the edge of our solar system. So it's 17 light hours away. Now, whenever scientists are communicating with it, that means that it takes the information at least 17 hours to get there, and then the information to come back another 17 hours. Look at this one. Now, do you remember Proxima Centauri or Proxima Centauri? We talked about it the other day. It's the closest star to us that isn't the sun, so the closest star outside of our solar system. So this is the closest one, and it is 4.2 light years away, which means if you look up into the sky at night and you look at Proxima Centauri or Proxima Centauri, you're seeing that star as it was 4.2 years ago, because it's taken that long for the light to come and reach us, and that is the closest one. So think about all the other stars and how long ago in time you're looking whenever you look at them. It's cool, isn't it? It is, it's cool. Go on, admit it. Now, other ones, our closest galaxy, do you remember we talked about it last day? Andromeda is the galaxy which is closest to our galaxy, which, if you remember, our galaxy is called the Milky Way, and it is 2.5 million light years. So we said last day that the Andromeda galaxy, we can't see it with our naked eye, we have to look through telescopes. This will maybe start to explain why, because the light that is travelling from it, it would take 2.5 million years to reach us. And then the edge of the visible universe is about, I think it's really 46.5. So I just rounded up there to 47 billion light years away. So that is how long it would take the light to reach us from there. See what I mean about the big numbers and being hard to visualize? So if you turn over to page 162 for me, please, that's just all this is saying. The light from the sun takes just over 8 minutes to get to us. This means the light is 8 minutes old. Light from our nearest star is 4.22 years old. When we look at that star, we're really looking 4.22 years into the past. And the further away we look into space, the further into past we see, because it takes the light longer to reach us. Now, over onto 163, one of the big questions is really like, well, where did this all start from? And the leading theory for that is the Big Bang Theory. I'm sure you've heard of it, even just from the program. So this is a very brief summary of it, and if you go on to do GCSE physics, you do a little bit more about it in it. So let's just read through this. So whenever observing the stars in distant galaxies, scientists noticed that we're moving away from each other and from us. And see that's actually really cool, the way they noticed that. So again, if you do GCSE physics, you learn a wee bit more detail about this, and you learn about how they discovered that. So this evidence suggests that the universe is expanding, because no matter where they looked, they found evidence that everything was moving away from us. So that suggests that if we were to go back in time, everything started from the one point. Okay, so if the universe is expanding, it must have started with huge amounts of energy from an unimaginably huge explosion or Big Bang. So this is a theory. We haven't yet got all the evidence to prove it completely, but it's the best explanation we have for the evidence so far. So since the Big Bang about 13 billion years ago, I think actually now scientists say 14 billion years ago, the universe has been expanding in all directions, and it is still expanding now. So we think that during the Big Bang all matter was created, and that just means everything, literally everything that we know, everything that we don't know, was all created during that Big Bang. Particles formed and joined together, and then eventually stars and planets were formed into galaxies. There are millions and millions and millions of galaxies in the universe, which we talked a little bit about last day, and trying to get you to count those ones in that picture. So last little bit for today, apart from those videos that I do want you to watch, is just to try and find the words in this word search, which would be the answers to these clues here. Okay, so do this and then watch the other videos that I'm going to link for you. Right, that is us. I'll see you next day. Bye.